Now let's look at a second uniform motion example. It says a motorboat has upstream a distance of 24 miles on a river whose current is running at 3 miles per hour. The trip up and back takes 6 hours. Assuming that the motorboat maintained a constant speed relative to the water, what was its speed? So before we go over that 5-step general procedure solving word problem, let me give you a very brief analyze of this problem. Why there are so many speeds, what's going on here. So if the river doesn't, goes up or down, okay, just a flat, let's say it's a horizontal, and so the water, let's say, just be still, okay, no moving at all, and then the motorboat, the travel rate is at a constant speed relative to water. But if the river, have a little level up, okay, so the boat can go upstream, okay, if this is a river, and then the boat can go downstream. Okay, so what happens when the boat going upstream? So boat have its travel rate at r miles per hour. Let's say we just use the variable r represent the boat travel rate. And then the current, now current is not still, okay, current is also running. And the problem saying the current is running at 3 miles per hour. So current actually going downwards, right? 3 miles per hour. Both going up, currents going down. So actually, because the current is moving, is prevent the boat moving at the same rate as it, travel in the still water. But on the other hand, when going downstream, okay, going downstream, and then the current going down also is 3 miles per hour, and then the boat also travel the same direction, r miles per hour, right? So when they travel the same speed, and then the water actually is accelerate the boat moving, so make boat moving rate actually faster. Okay, think about that. Can you understand this situation? If you can understand this situation, and then that will much easier to set up the model. Okay, so now let's go through our general 5-step process. So first step, we need to identify, the unknown quantity, right? What we're looking for. We're looking for the motorboat travel speed. Okay, motorboat travel rate is unknown quantity. Since we only have one unknown quantity, so we just let r to represent it, okay? Just use one variable to represent one unknown quantity. And then step 3, we need to translate the already known factor into mathematical expression, right? And then identify the model. So since this is the travel problem or uniform motion problem, so let's use a table, help us organize all the information. Oh, actually, we only need 2 rows. All right, anyway, the upstream, downstream, okay, and then the travel rate, travel distance, and then travel time. Okay, 3 elements. So the travel rate when motorboat going upstream, since the current flows in the opposite direction, so actually slow down the real actual travel rate, right? So the motorboat travel rate should subtract the current travel rate, thus get the upstream travel rate. And an upstream travel distance is 24 miles, right? That's given by the problem. So the travel time for upstream should use the distance 24 divided by the travel rate going upstream, which is r minus 3. And similarly, when the motorboat travel downstream, the rate, what should be the rate now? Travel rate. So the motorboat and current travel the same direction, right? The actual travel rate is accelerating, so that's r plus 3. And then the travel distance still 24 miles, just a round trip. The distance remained the same. So the travel time for downstream should be distance 24 divided by r plus 3, right? So now what is the equality here? What's equal? We know the total travel time, round trip up and back takes 6 hours. So this is the up travel time. This is the downstream travel time. These two add together should equals the total travel time 6 hours, right? So that given us the equation. So let me write it. 24 divided by r minus 3 plus 24 divided by r plus 3. These two times add together should equals 6 total travel time. So how to solve this equation? We noticed we have denominator, okay, so the mathematical speaking, we have some restrictions, which is r cannot equals positive 3, r cannot equals negative 3. But in the real world, r represent a travel rate cannot be negative, so we only need to require the motorboat travel rate cannot equals positive 3. Okay, that's the restriction. And then let's solve this problem. So we want to get rid of the denominator, right? So in order to make least common denominator, the first term, we would like to multiply by r plus 3. Okay, I put on the left-hand side. And then we multiply both numerator and denominator by r plus 3. So equations still keep equivalent. And the same thing in the second term, both numerator and denominator I multiply by r minus 3. This is r, okay, not x. All right. So now left-hand side equation, both terms have the same denominator, which is r plus 3 times r minus 3. So the numerator we can combine, right? They have a common factor, 24. We can factor that out, and then remaining factor will be r plus 3 plus r minus 3. Is that right? Okay, and then we can further simplify. So you notice plus 3 minus 3 cancel. So numerator just 2r times 24, which is 48r. Denominator, that's r squared minus 9, right? The two conjugates multiply. That's just the first term, last term, equals 6. Right? And then both sides of equation, 6, 48, they have a common factor, so we can simplify both sides divided by 6. So that's 1 divided by 6, that's 8. So we got a 8r equals, and then multiply the denominator on both sides, r squared minus 9, right? Both sides of equation multiply by r squared minus 9. And then we got a quadratic equation. Okay, so let's write in standard form. I don't have space, and I move on the left-hand side. So standard form of this quadratic equation is r squared minus AR minus 9 equal to 0. So we can easily find a factor form. So we're trinomial we factor as 2 binomial multiply, right? We're looking for 2 factor multiply each other equals -9, and this 2 factor add together equals -8. So it's obviously is -9 plus 1. And then 0 product rule, we can let each factor to be 0. So that's r minus 9 equal to 0 or r plus 1 equal to 0. So we easily solve either r equals +1 or r equals -1. Again, r represents the motorboat travel rate, right? So it cannot be negative. So this solution we can discard. So finally, we know the motorboat constant speed relative to the water is 9 miles per hour. All right, that's how to solve this uniform motion problem. And that's the book setup. Okay, it's also put it into a table format. And then this is the picture. You can look at it. So that's better illustrating the situation here. And then that's solving the equation.